Alright, so this problem is another one of these VaR problems. We have a $500 million portfolio. It currently has a VaR of $15 million. We'll check and see if that's actually correct. We can calculate it ourselves. They have a risk tolerance of 0.25. At a risk tolerance of 0.25, let's go down to the normal table. What are we looking for? A risk tolerance of 0.25.
1 minus.
Risk
1
tolerance.
minus 0.0025.
1 minus 0.0025. We're looking for 0.9975. So can y'all find that in?
2.81.
Here it is right here. 2.8 or 1. So that's 2.81 standard deviations from the mean. Right? So Gada, you're now officially in this video, so that's good. Should have warned people that we're doing video. So that's good, now you'll be famous. Alright. So you've got 3 strategies in addition to your current strategy. So it's very similar to the problem we did last time. And you're going to do 20% to one of these strategies. You want to know which one to do the strategy to. And so here's the different options. The current strategy has a return, expected return of 7, standard deviation of 6%. A is higher return, higher risk, but a negative correlation. B, lower return, lower risk, low correlation. C, a really high return, comparable risk, but not a very great correlation. And so your boss is asking which to allocate to, and then do a graph to say which is the best recommendation. And then we'll get to this question C at the end. So the first thing we should do is calculate expected returns. So we've got the current, and we got the current with 20% A, with 20% B, and 20% C. Y'all let me know if I'm going off the edge. Expected returns are the easiest of all. So the expected return for current is 7%, so that's a piece of cake. The expected return, if you have 20% in A, will be 0.8 times the 7% for current plus 0.2 times the 0.074% for A. If we work that out, y'all don't want to check my math. I get 7.08%. Somebody else got that too? Does that sound?
Yes.
That sound good? Now, we may have some rounding issues because I'm using an unrounded answer key. So the same thing with B. With B, we'll have 80%. That's 7% plus 20% at 0.065. And then for C, we'll have 80% at 7% plus 20% at 7.8%. So when we do those, we should get 6.9% and 7.16%. Now your boss in this particular case, she didn't say anything about any limitations. So if you're not getting any limitations, we either want to increase return without increasing risk. We want to reduce risk without hurting return. If we can increase return and reduce risk at the same time, that's obviously the best answer. Since they've already done most of the work for you and said they just want to put 20% in one of these, then you're limited in what you can do. But if they didn't say that, what would you do? What did we do last class? You set it up in Excel, run solver, and let solver tell you what the best answer is. But we're not doing that because this is an exam, so you don't have a solver. So then we got to do expected risk. And for expected risk, we use this formula. So for the risk of current and A is going to equal the square root of the weight of A, which is 0.8 squared, times the risk of A. And what was the risk of A? 6%. 6% squared, plus the weight of, current. So the current, 80% current, 6% risk for current, and then the risk of A, the weight of A squared, 20% squared, times the risk of A, which is 7%, plus 2 times the weight of current, times the weight of A, times the risk of current, times the risk of A, times the correlation of A and B, which is negative 0.1. And when I do all of that, I've lost my insert key. When I do all of that, I get a risk of, where is, wow. All right, what, you might calculate that, so let's do that calculation really quick. Sorry, my answer key doesn't look right. So we'll check my work so we make sure we don't have wrong answers. Does anybody have an answer?
Okay.
4.86.
Yeah.
4.86?
Yes.
All right. What's the risk of A? 0.06, 6%, right? That's just given in the problem. So that's 6%. Well, that's pretty impressive. The risk is much lower, and the return is much higher. A is an awfully strong candidate just to start with. All right. So now we'll do B. The risk for B is 5.6, and the correlation is 0.2. So 0.8 squared plus 0.06 squared plus 0.2 squared times 0.056 squared plus 0.8, I'm sorry, plus 2 times 0.8 times 0.2 times 0.06 times 0.056 times positive 0.2. Y'all check that work and see what you get.
I got 5.14.
514, anybody else getting that number?
Yeah.
514, that looks good to me. All right, B, the problem with B is that you lose return. You reduce your risk quite a bit, that's good. But you're also sacrificing return, that may not be so good. And then we look at C, so 0.8 squared. These are all times 0.06 squared plus 0.2 squared times the risk for C is 6.2%. 0.062 squared plus 2 times 0.8, 0.2, 0.06 times 0.062 times correlation is 0.4. You'll try that.
I got 4.96.
Get something higher than that. Get 5.42.
Yeah.
542?
What do you get?
All right, so
Unless it's a VaR.
your two candidates at this point are A and C. C has higher risk than A, but gives you more return. There's absolutely no reason to do B because it has a lower return and higher risk than A, so no reason to even consider that one. The next thing we want to do is get the VaR. All right, well, to get the VaR, what's the formula we use for VaR? VaR at 0.25% risk is going to equal the mean minus, what did we say, 2.81 standard deviations times the standard deviation. But we're going to state it in absolute terms. So for the current, we have 0.07 minus 2.81 times 0.06. And that gives you a VaR of 9.86. Does that sound right? Y'all correct me if I don't have it. The next one is a mean of 0.0708 minus 2.81 times 0.0486. And I get 6.58. Again, y'all stop me if you get a different answer. The next one is 0.069 minus 2.81 times 0.0514. And that gives me a VaR of 7.54%. And the last one, 0.0716 minus 2.81 times 0.0542. And it gives me 807. Anybody disagree with those numbers? For some reason, my answer keys rounded off strange. What I did, my answer keys, so something strange happened.
So you got it by you.
And I know my answer key is wrong because it shows the risk of the current strategy is 6.05%, which the given number is 6, so it can't be that. Anybody disagree? I'm hearing murmurs, no murmurs, or it's good. All right, there's the VaR in percent. Let's do the VaR in dollars. Well, how large was the portfolio? The portfolio is $500 million, so we just take these percentages times $500 million. Let's see what we get. So I get 49.3. 32.9, 37.7, and 40.4. Those are in dollars, in millions. So we said that the current VaR, the portfolio's current VaR was 50 million, but it's pretty close. It's 49.3 million. Everybody agreeing with me on the numbers? I don't hear a lot of calculators clicking, so hopefully you are checking more. Nothing worse than every math error and everybody leaves with it in their notes. You get what? On the which one? Well, there's probably a rounding issue at this point if you're doing an Excel because I'm using the rounded numbers. So if you're within a little bit, it's probably good. I mean, I can tell you the exact numbers.
It's only within,
This is like 32.883, 37.717, 40.3. Well, I'm using rounded standard deviations too. So rounding's not an issue. Show all your math on the exam because if you make a math error on the cutoff for it, if you just make it once, it doesn't. All right. So what does your boss say? Question 1, which allocation do you recommend and why? Well, there's not too difficult. We're going to kick B out. Everybody see why we're kicking B out? All right. So it's between A and C. Well, between A and C, she didn't give you much guidance. Except for, she just said, she has expressed a desire to reduce the VaR below 35 million. So does that help you any?
No.
Yeah. She wants to get the VaR below 35 million from 50 million. So she really wants a huge risk reduction, which is the reason they're doing this. So obviously that $50 million VaR was just too much for their clients. So A looks like the right one. C was a contender. It just didn't get the VaR low enough. And that's because this correlation was a little too high. So A is the one we're going to go with. Why? A increases return. And we should always use the word expected. Increases expected return a little while getting VaR to below desired level. Kind of makes you worry that wonder where that 35 million came from. I'm guessing she's already run the numbers before she gave this to you, just to see if you can get the right answer. So this is a big test to see. All right, everybody's good on this page? So we got all these numbers? The second thing she says is, you know, the board likes pictures, so we need a graph. Now you have several ways you can do the graph. We generally put expected return in percents on the y-axis, but the x-axis you could do any one of these things. I'm going to say, since she came in and said that she wanted a VaR below, and she said it in dollars, 35 million, I think the smartest thing to do would be the graph dollars, because that's what she said. So I'm going to do a graph, and on your graph you want to label it. So what is over here? Expected return. And down here is the expected VaR. I don't know if you can say expected on VaR, but we will. At 0.25 dollars in millions. All right, so the current strategy has a 7% expected return. One, 2, 3, 4, 5, 6, 7. So 7% expected return. And let's say there's a VaR, there's 50 million, just below 50 million, slightly below 50 million, and right at 7%. There's our current. I can't draw these things well, so just imagine that this is symmetrical. All right, strategy A has a slightly higher return in 32.9. So right here, slightly higher return. So 20%. A. B has a 6.9% return, so slightly below 37.7, so somewhere right around there. And then C has the highest expected return, but the risk right about there. And then what else might you put on the graph? You might say target 35 million VaR. So here's your target VaR. So the only one that meets the criteria is A. So you might put something in to help them see where to put it. So we know we can do better than B. We know we can do better than current. You kind of have a little bit of efficient frontier forming there, maybe a little bit, not real dramatic, but you're definitely seeing A and C is out there helping you find optimal portfolios. All right, everybody see how to draw this? If you don't put expected return over here on this axis, you need to label a little bit. I should put some numbers here. So make sure you label it, and then expected VaR. And it's sounding strange to me to say expected VaR, because we know by definition VaR is an expected number. So returns, they can be historical or they can be expected, but VaRs are, I don't know even said our historical VaR is. That seems kind of strange to me. VaR is an estimate of something. So probably be strange to say that. I don't know if someone might do that phrase. All right. Now the problem with this graph is I probably should have limited it. So you might want to draw it twice. So if I were to draw it again, I might draw it just from 30 million to 50 million. Have it start there, and I might start my returns from 6 to 8, blow the graph up so I can see these points a whole lot better. So you might try thinking about scaling. It would be a lot better if we could do this in Excel, right? So you could let Bill Gates do all the work for you. So we might scale this out to be a little bit more visual.
In the calculation of the VaR percentages, the X bar, the average, is that the average of the standard deviations or the average of?
No, it's the expected returns.
Expected returns, okay.
Yeah. What did I write down? Did I write the wrong thing?
No, it's just, I didn't know what it was and it was killing me.
Yeah, X bar is the expected return.
Gotcha.
That's the definition. I mean, that's the definition of VaR. It's how far away, at some percentage, can you be from your expected. That's how we define risk in finance. How far away can you be what you expect? The further away you can be from what you expect, the more risky something is. All right, what's her third question? Her third question is a little bit unusual. And it's not even her question, maybe. This is something that you noticed. Your boss is concerned that parametric risk may not fully capture the true risk of these strategies. You ran a 10,000 simulations with the worst ones showing here below. You have the dollar bars for each one of these, 40, 49, 32, 37, and 40. Which of these simulations are we interested in? Well, we ran 10,000 simulations. Our risk tolerance is 0.0025, so that equals 25. What's the 25th one from the end? So it's going to be 9976. You take 10,000 minus 25 plus 1, 9976. So we can add this in. So we have our stochastic VaR. What kind of VaR is this? That's the parametric. So here's the stochastic. And the numbers we get were 56.35, 38.5, 44.43, and 45.75. So what do you notice on every single case? Stochastic is much higher than parametric, and that's pretty common actually in practice. So what does your boss say? She's worried about the parametric VaR may not fully capture the true risk. Discuss whether this model output raises concerns and what might be the cause of those concerns. Okay, so stochastic shows more, if you want to say it like this, tail risk or downside risk. And parametric VaR this may reflect that loss pattern is skewed to the downside, while parametric VaR assumes what? Parametric VaR using standard deviation, assumes symmetry. You can't be skewed to the downside if you have symmetry. Because symmetry, by definition, you don't have any skewing at all. It's just perfectly reflected on both sides. Why in the world would a stochastic model be a more accurate picture? Well, you have more flexibility in a stochastic model. You can add different types of, if you want, like we talked about correlation, if you want to say, hey, in a crisis, make the correlations all move to 1 or closer to 1. Well, that's going to skew you on the downside if you do that. Versus with parametric VaR, you never change your correlations. They're always constant and static. So, all right. Good. the, because it's still running hopefully.